Alright guys, well I am back. This will be part 2 of this adventure I'm going on with this Tektronix 576 curve tracer. So it's begun, as you can see. We are well underway here, and I just dived right in. As I was saying in the last video, you know, definitely something going wrong with the power supply, the low voltage regulator board. All the voltages were just low, out of spec, and there was a lot of ripple on all the rails, which the ripple was also out of spec. So, you know, it would lead me to believe that there's a filter cap somewhere in that circuit or filter caps in that circuit that are causing that ripple. And you know, you have these big caps that are behind the low voltage regulator board, which I was able to remove. That's this guy right here, and then behind this board is the low voltage rectifier board. So that's where all the bridge rectifiers are. You know, I looked at these boards, and all these orange caps tested fine. Couple electrolytics, or a few on here, might be suspect. If you know, there's a few that have high ESR values, but their values seem to be within range. So I might just, to play it safe, replace some of these or all of them. And then, so yeah, I had to remove those to get to these bigger caps, and you know, fortunately they come out this way, so I was able to remove the ones of interest without having to remove the CRT. I'm really hoping I don't have to remove this throughout this whole endeavor. But yeah, so you know, I mean, I'd mentioned this earlier, but you're not going to find any Molex connectors, or, you know, like, every single wire is individually connected to every board. Okay, so I just labeled every single wire I removed. I am not taking any chances. The schematic, or at least the one I found, and this thing is over 250 pages long, so I haven't looked through all of it, but it doesn't give color coding for the wiring. At least I haven't been able to find it yet. I'll be honest, I didn't dig that hard, but you know, wires fade over time, they get dirty, so I just labeled each wire that I've removed. And you know, that might be a pain in the ass to remove that tape down the road, or gets in the way, but I think I'll be glad that I did that. So that's what all of that is. Yeah, I mean, it also really slows this process down, you know. So I spent a lot of time doing that first, and then removing the boards. I mean, another thing is, while this looks really nice and neat, I mean, all of that wiring is just tied together, and I've debated whether or not I don't want to remove it, and there's no way I'm gonna. I mean, I guess I could, you know, if I start moving this, zip tie them, but I mean, this just looks so cool the way they used to do this, and I don't want to cut into it, but there may come a point when I might have to do that for some of it. You know, again, this isn't. I'm not looking to restore this to its, in the sense of like keeping everything to the original 1968 spec, or whenever the hell this thing was made. But you know, I do really appreciate the way things were made back then. I love it. Almost looks like art to me. So you know, I do want to keep that integrity to some respect. But anyway, so that's kind of where I'm at. I did have to also remove this. We spin this guy around. This is the high voltage power supply board. I had to remove that so I could get to these caps, to get to the screws in the back. But yeah, so I guess I can just go over so far what I've found. These caps, these big boys, almost all of them tested fine. And now I haven't removed them from circuit, but they all tested within spec, low ESR, so I'm not really too concerned about these. But there is one cap, however, that is a big problem, and it's this guy right here. This is cap 707. It should have a rating of 200 microfarads. It is, well, this is at 100 kilohertz, but frequency, but this is 300 picofarads. And the ESR is through the roof. Yeah. Nanofarads, 500 nanofarads, 21 kilo ohms ESR. So this cap is shot. This cap plays a very important role. It is the negative 75 volt rail is across this cap, and that rail is extremely important to this guy. I don't know why yet, but it's got the tightest spec as far as the accuracy for it. There is a there's a trimmer cap on the board. I mentioned that in my first video. It is this guy right here, this trimmer capacitor. That is for adjusting the voltage, and I had mentioned that in that last video I adjusted that as much as I could and only could get it to negative 65 volts. So that guy could be why we're seeing ripple across. I mean, I don't know. It could be it could be the reason we're seeing ripple across all the rails, but I am not 100% sure on that. There's definitely going to have to be a bit more testing and looking at the schematic to figure that out. It's going to take me a while to figure out what kind of would be a suitable replacement for this guy. I mean, they don't make these anymore. They make similar style ones, but one that would fit this little insert, which I really dig. Yeah, that's not gonna be likely unless I find new old stock of this, but we'll see. Well, that's another approach. So there might be some time in between my next video. I might, while I'm waiting on that, take a look at the step generator board, which is this guy right here, and that's the amplifier right there. I'll be taking a closer look at those, but yeah, it's going to take me a bit to get this back up and running, and it might sit for just a little bit, but hopefully not too long. But yeah, that's kind of where I'm at right now. Let's see if there's anything else I got right off the bat. Yeah. Haven't found anything else really, no more other nothing. Still, as I dig further into this, there's still nothing that's jumping out at me that screams like there's an issue. Like no burn marks, no cold joints, solder joints, or anything like that. So yeah, still this is we're still moving along though. Oh, another interesting thing that I've noticed is all of these transistors, they're not soldered in anywhere. They are literally they are just socketed, which I thought was interesting, but that makes them placing those a bit easier if I find any bad ones. But yeah. So I've been kind of struggling with what to do about replacing this C707 filter capacitor that's bad. And as you can see, I've gone the route of completely dissecting this thing, and I have a reason for it. I've heard of people doing this before. Um, in restorations of old electronics, whether that be mainly old radios, tube radios. Um, and I always thought it was kind of silly. I mean, I've actually restored a couple old radios as well, and you know, who's really looking on the inside of these things other than me? I get it, I get wanting to keep it a period piece and authentic, but you know, but I I was really struggling with ideas for finding an alternative to replace this guy. Now, they don't really make caps like these anymore, at least from what I could find. They don't make electrolytic caps with solder lugs, or at least they don't make very many of them. So, you know, I was really struggling to find um, a suitable alternative on, places like Mauser and DigiKey. I did not want to go the route of trying to find new old stock, even though I did look and I didn't see anything for this particular value, although I did find a couple of these Sprague aluminum can style caps. Um, but that can be really expensive, and it's a what, uh, 50-year-old cap, maybe older. I just, it just didn't seem like a good way to go for me. But yeah, but I did want what I did want out of this, whatever alternative I get, would potentially be something that could still fit in this insert and be, and ideally still be able to get screwed in to the chassis. So, um, but yeah, I wasn't having much luck. And so I did look up on how to gut one of these old caps and stick a modern one and that's what I did here. So what you can do is, and I this is not what I'm recording the video on the restoration of this Tektronix, not on how to do this with these caps, but I'll go over this briefly. So if you look, maybe I can pull up one of these other ones. You're probably not gonna be able to see it too well, but yeah, all right. So you'll get the idea from this. Anyway, this outer edge here is crimped over the bottom of the cap, which was this guy right here. That you could still see. That had the positive lead coming out of it. Actually, no, I'm sorry. That's not this guy, actually. Yeah. This is what you could see on the bottom that had the positive lead coming out of it, right there. It was crimped over that, this can, and so really all I had to do was just kind of uncrimp it, and I did it. Didn't do the cleanest job, but I used a combination of tools. I didn't really have a small pocket knife on me, so I used this guy, which I use for removing O-rings. That kind of came in handy. And then once I got it off a little bit more, I moved to a small flathead screwdriver, and that worked pretty well on uncrimping it. And then from there, it was a series of this plastic piece, this rubber gasket or cover was there. Then I think it was this piece after that, and then finally we came to the actual capacitor, which is this guy right here. And you can see it's still kind of like soaked in like that electrolytic. It's not, completely dry. That's one of the leads. I believe that's the negative terminal, and I think this was the positive lead, and it just broke right off. The rest of it is right here. So that negative lead would connect to this guy, which you have these 4 terminals, which are all just the negative side of the cap. And then this guy crimps over top of that. So this is also at the negative potential of the cap. So That's why they're covered with that plastic piece, because, unlike one of these, don't you don't want to touch one of these. You're gonna have a bad day. So, yeah. So what I'm planning on doing is, this is the only cap that I have on hand that is close enough to the value of that guy, which is a 200 microfarad, 250 volt DC. Um, so yeah, this is what I plan to use. I was thinking of, maybe I have some. This is unfortunately a snap-in type. I don't have any caps that have like longer leads, which would have been more ideal for this. Um, in stock, I had a couple that were a bit smaller, like 150 microfarad, or a bit larger, but yeah. So I think I'm gonna give this a try and rig something up here. Um, Another thing that I've also bought, but would might be a better route to go, is these. I found these on searching some forums. Also, I saw a YouTube video of someone who's restoring one of these. I really don't want to watch videos on restoring this guy. I really just want to go the route of using only the service manual and my own limited knowledge of electronics to fix this. But this guy kind of stumped me a little bit on the best route to go. And so anyway, I found someone who was using one of these capacitor adapters. And so your cap would go into these leads here, and then you could fashion something on the connect the other wires that connect to the negative on the outer vias or holes from Osh Park. So I did order some of these, but unfortunately I don't have a lot of patience. I need to get better with that, but yeah, I just wanted to see if this was feasible. I'm gonna give it a try. If it just doesn't seem like it'll work, or just not robust enough, I'll wait it out and use one of these. And yeah, so let's see what I can come up with. Alright, so this is what I came up with. We aren't quite done yet, but just wanted to show you before I stuck it in the can. So I looked at this a few different ways, and I couldn't really come up with a better way to connect the cap to these leftover connections from the original. So like this solder lug, and then the 4 lug ring. I just didn't have. I just couldn't come up with anything else to make a secure connection. So, this is what I came up with. So what we have here is the snap-in capacitor, and so this is the only size wire that I had on hand. I think it's definitely probably too thick, but can't go wrong with that for better than too thin. But yeah, so I crimped the wire to the snap-in cap with a few of these. The correct size. I have a couple different sizes. I think it might have been one of the larger ones, but anyway, I crimped that to the cap, and I mean, that's not going anywhere. It's on there really, really tight. Then put some heat shrink around both those connections, so that just to prevent any potential shorts. And what I plan to do is with the negative lead, that I'm just going to connect to the ring with one of the available solder lugs. Not all of them are used. For example, that one right there isn't used. We'll just solder that lead to that. We'll cut this original the original tab, because we don't need that anymore. And then for the positive lead, to get it to connect to the positive lug that was left over, I used one of these spade connectors and just crimped the hell out of it. It fit. It was almost a perfect fit, but it just wasn't. It's a little bit thinner than your typical spade connector, so I crimped it real good, and kind of bent it a bit so it'll stay in place. But yeah, this is what I have. I think I'll just keep the original. That's just some foam in there so the cap can sit in that, and we should be good to go. I think this will work. But yeah, I just wanted to show you that before I put it back in the can. All right. Okay, it is not as pretty as I had hoped, but it works. God damn it! So, and I know it's 220, but that's just the that's just the spec. That's 20%, I guess. That's what this cap was. Yep. So that's gonna work fine. Unfortunately, I'm not gonna be able to reuse this. I just couldn't get it in there. I couldn't get the lug sticking out far enough, but it'll work. The insert will work just fine, and I can feed the screws through that. It's not gonna pop past this due to the poor re-crimping job I did. So this will work just fine. We don't need that. But now for the real test, I'm gonna pop it back in and see if our ripple has gone down and our accurate voltage rails have come up. These boards, I'm pretty much gonna give them my blessing. All these electrolytics I removed and tested, and they are fine. They are still well within spec. They have low ESR, so I'm not worried about those. And these also are all testing accurately, bang on at 22 nanofarads. ESR for some is a little high, so I might end up replacing those, especially if we don't notice an improvement in some of the voltage rails. But we'll see what happens. We'll make a decision on that when we get there. But all right, let's see what happens. Well, I am back after putting the caps back in and connecting the low voltage rectifier and regulator boards. I didn't screw the caps back in, or some of them I didn't even put their plastic shields back on. Because I just wanted to see what would happen. I wasn't sure if it would bring the voltage rails back into spec just by replacing that one cap, but check it out. We are at minus 75 volts on the minus 75 volt rail. I mean, we are bang on. And now, when I first powered this guy on, I checked the 100 volt rail first, and it was at 122 volts, and I was like, oh geez, what did I do? And then I realized that that trimmer pot R721, I believe, that was still turned all the way up. So or as far as it could go to the right. But yeah, so as soon as I brought that back down, going back on the minus 75 volt rail, which due to that being at all the way up, it was in the 90s, but we was able to dial it in to minus 75 is where it exactly should be at. It has a spec of plus or minus 0.375 or something like that. Checked all of the other rails and everything looks great, with two exceptions actually. So the 5 volt rail is actually at 5.5, and the 4.5 volt rail is at 4.1. I think they let's see what the spec is for those. I don't know off the top of my hand. They're kind of wide. Yeah, so 5 is plus or minus 0.25, and then the 4.5 it says variable, so I'm not quite sure what that means, but it's plus or minus 0.3 volts. So we are technically out of spec on both of those. I'm not quite sure what the reason is for that, and we'll see what the I haven't checked the I also haven't checked the ripple yet. We'll do that next, but probably to find out at a later time what's going on there, if it's a problem at all. But otherwise, everything else as far as voltage accuracy is right in spec. So we're looking really good there so far. Another thing that I noticed is if you look at the display, the trace has just gotten a lot more defined. I don't want to fiddle with that too much because I did disconnect this is the focus and the intensity pots. So they're disconnected from the shafts, and I don't really feel like playing with those a bit. They obviously have some really heavy duty wires with a thick gauge, so that probably means there's some high voltage running through those potentially. I just don't want to mess with them too much. But still, I mean, that looks a hell of a lot better than it was before. Let's see. If we go to AC, you can bring it. It just looks a lot more defined and brighter. Again, the intensity might be brighter, but still, it just looks better. And time will tell once I'm not really too sure if I'll be putting everything back together yet to mess around with it, because we obviously know there's still some problems, and I don't think that just fixing the power supply is going to resolve them. For example, these buttons that are for the step generator settings, they're all screwed up. They don't depress properly, and the calibration button doesn't work properly. Let's mess with that right now. We need to go to 10x, and what else do we need to do? Yeah, let's press the cal. Yeah, I actually might not be doing that correctly. I think yeah. Yeah. So anyway, yeah, see, that's the thing that see, this works properly when switching to the horizontal and the vertical offsets. That is how it should look. But pressing the cal button shouldn't make it disappear from the screen. That's what I'm referring to by the cal button not working properly. So, yeah, there's still something going on wrong there. And yeah, so I don't know if I'll be going back anytime soon and testing components and things like that. I do want to do a bit more investigating here. But yeah, I got carried away there a little bit. Let's move on to the looking at the ripple for the power rails. So I've got the oscilloscope hooked up to the negative 75 volt rail, and check this out. So I initially had it in DC coupling mode to check the rail, and actually that's what I had it in when I did the first video. And you could see just how bad that ripple was on on the rail, on the I forget what rail we looked at the time, but all the rails, it was really bad and well out of spec. Now I have it in AC coupling mode, the oscilloscope, so that we can remove the DC components of the signal and just get the AC component, and check that out. I mean, we're at 20 millivolts per division, and I mean, we're not seeing any of that 120 hertz ripple that we were seeing before. Now, the service manual says the spec for total output noise and line frequency ripple peak to peak is 5 millivolts. I mean, I don't even know if this scope is capable of that type of resolution. I think it might have that kind of noise regardless of any signal that's put into it. So I will definitely take that. I mean, the scope is saying, yeah, 15 millivolts peak to peak. I will take it. I mean, and by the way, that's for all of the rails. We're not seeing any more of that bad ripple that we were seeing before. In fact, I looked at the 4.5 volt rail and the 5 volt rail on the scope, and that measurement there, we're within spec. I got about 5.1 or 5.2 for the 5 volt rail and 4.3 for the I'm sorry, 4.2 for the 4.5 volt rail, which are both in spec. What's interesting is the service manual that I found online says to check the 5 volt rail at pin R, and this low voltage regulator board has no pin R. It has all the letters on the left side, A through Z, except R, which is interesting. It seems like pin Q is the 5 volt rail. Another thing while I'm on that subject is I was trying to get some information again on finding a suitable alternative for that big cap. And someone had mentioned to me that these guys were made up until about 1990. So they basically just kept making them until parts ran out, which would make a lot of sense regarding that high voltage interlock, that little board. It had copyright 1985 on it. So I might have gotten one of the newer scopes. That's the serial number right there. I don't know if you can check the serial number and match it to a date. I'm sure some of the more seasoned Tektronix owners might know, but I certainly don't. Another thing that I noticed is I got lucky here. That black transformer, that's the high voltage transformer, and I've also heard that if you have a black potted transformer, you are in the clear as far as those high voltage transformer issues. If they are brown potted, that likely means you're going to have some issues if you don't have them already. So made out pretty good in that respect. But yeah, we are making progress here. Next steps, again, I had mentioned this earlier, are going to be checking the step generator. That's the board there, and then there's the amplifier board, or step generator amplitude board is right here. And of course, all these switches for the step generator families and the rate, those switches need to be looked at, potentially replaced. And then even, I'm going to have to look at the cowl and switch, the zero and the invert buttons. They do work, but every time you press them, the trace goes all over the place and gets all crazy. So those might just need to be cleaned. But yeah, I'm going to have to find a way to get to those. They are buried fairly deep into the, you got all these boards on top of it. I was hoping that maybe I could take these out, but unfortunately, the chassis, it blocks those screws, you can see. So, yeah, that's going to be potentially difficult. You can see that they're on a sub-chassis, so I might just have to remove this guy, but that's also going to be a pain in the ass. So I am not quite sure how I'm going to tackle that. I might have to look at the service manual and see. I know they have like exploded diagrams and stuff, so that might put me in the right direction, but we aren't done yet. There's a lot a lot ahead, but this was a very important step, and it looks like we've already gotten some really nice results as far as the CRT trace improving. At least I think it did. I might just be psychosomatic, but it really does. Because even when you would move it, like for example, we'll put it in NPN mode. Yeah, so even when earlier when I had it in NPN mode, for example, the the trace would get like it would just become more like of a slanted line versus a fine point. Whereas now it just looks a lot um, it just looks a lot better than it did before. I mean, yeah, yeah. I mean, it looks so much better. So I really think that that is related to um, the power supply issue that we had now being resolved. So yeah, that's excellent news. I am ecstatic about that. But I think we're gonna wrap up now because next steps are gonna have to be. I'm gonna have to come up with a game plan here for that. So thank you guys for tuning in, and there's gonna be more to come. So all right, catch you next time.